Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about a very important category of multiple access protocols that is known as taking turns protocols. So, in this category we have different varieties of procedures. One is called as reservation, other one is called as polling, and other final thing is called as token passing. So, we are going to see what actually the token turns protocol stands for here. So, before going to the details of the lesson, class is concerned, just we are expecting some learning outcomes from the students. So, after completion of the lesson, the student will be able to know about the fundamentals of the taking turns protocols and also the details of reservation procedure, polling procedure and token passing procedure as far as the multiple access concept is concerned. So, let us start with the introduction of taken turns protocols. So, actually the taken turns protocol is nothing but every station in the network, they have some data, but they should have the chance to use the channel, because in the multiple access the channel is common to everyone. So, the station has to first of all get the turn to actually use the channel. So, that is why in this particular procedure every station will have a turn. So, that based on that the station can able to use the channel and send the information. So, that this particular concept is referred as taking channel or taking turns protocols here. So, in this category, so it is actually based on a principle called as a controlled access. So, if every station is using the channel without any limitation, without any control, then there will be some problem with respect to the communication among the devices. So, that is why, so this should be done based on some kind of a control mechanism. So, that is why this is also known as a control access mechanism in the multiple access. Multiple access of course we encourage, but moreover it should be in a controlled manner. So, that is why it is called as a control access procedure. So, in this, so if you see the definition that is there, in controlled access the stations consult one another to find which station has the right to send. Suppose there are 4 stations which are there in the network, and every station, before they have the data to send, first of all they have to consult the other stations. So, in this controlled access the stations consult one another to find which station has the right to send. That means they should discuss with some procedure. Based on that they should have the confirmation to send the data from that station to the other station. So, that is why this particular kind of access is also referred as a controlled access by using the common channel. A station cannot send unless it has the authorization by other stations. Authorization means acceptance by the other stations, so that the station can able to use the channel for its own purpose. So, that is why it is called as a controlled access mechanism. So, in this there are 3 procedures we have to follow. One is called as a reservation procedure, next is polling procedure, and next is a token passing procedure. But whatever it is, all these 3 procedures are meant for usage of a channel on a common basis. It is actually designated, and it should be done on a controlled basis. So, that is why these procedures finally achieve a controlled access mechanism. So, by following certain steps. So, let us start with the reservation procedure. So, as the figure is indicating that, so there are some frames we are finding here, and there is one important frame that is running from left side to the right side according to the screen. I am saying that there is an arrow mark that is showing from that side to the head of the arrow. So, the frames are moving. So, among the frames, one is designated as a reservation frame, other one is called as a data frame. The reservation frame is an empty frame where blocks are there whenever the station is interested to send some information, it has to communicate in the form of a reservation request. So that is why once the reservation request is made by the station, in the frame one block will be filled with 1. Whenever 1 is noticed, then that particular station is actually putting a request indicating that it can use the channel whenever it is allocated to that station. So that is the meaning of 1 here, and whenever 0 is appearing in the frame, it says that no, that particular station which is numbered on the top of the frame on the block is nothing but saying that it is not having any data to send, so it can leave the chance to other stations to send their information. So that is why this reservation frame is very much useful to know by the stations which stations are ready to send the data, which stations are reserving the block for the channel, so that they can use the channel for their communication. So along with that, there is one more frame we are finding, that is called data station 1, data station 3, data station 4, like that. Whenever the reservation is made, the station is responsible to put its data in the actual frame. So that is why the reservation frame followed by the data frame can be identified in this particular procedure. So whatever it is, this particular procedure is to say that a station needs to reserve the actual channel for its communication purpose for sending the data. So that is why the stations along with the data that is existing at their end, they have to fill up the reservation frame based on their request for the reservation for utilizing of the channel. So by using or by filling the frame by number 1 means it is interested to send some data, or by putting 0, that means by default 0 will be there. Whenever the station is interested to put some data, it will be replaced with 1, so that the channel can be reserved for that. Whenever the turn comes, automatically the station can able to use the channel. So here in the reservation frame on the top, you are finding 1, 2, 3, 4, 5. They are nothing but the station numbers, and the respective reservations are made in the bottom block, that is 10110, which says that station 1 is reserved, station 2 is vacant, station 3 is and 4 is reserved, and station 5 also putting station 5 is actually not interested to use the channel. So this is the meaning that is actually communicated by noticing the reservation frame here. So by this, the channel is common, of course, and moreover it is in a controlled way. It is happening that the sending of data from the station to other station is possible in a controlled manner. So this is the way how reservation is useful. And the next mechanism is called as polling. In this polling, so if you want to have some clarity, I am going to show that the stations are classified into 2 ways. One is called as the primary station, and the all other remaining stations can be referred as other stations, secondary stations. So here the primary station is responsible to actually inform the secondary stations whether it is interested in the process of select function or in the process of poll function. There are 2 important functions you can identify in this case of the actual polling here. Polling works with topologies in which one device is designated as primary station and the other devices are secondary stations, as I mentioned. And actually in the figure you are able to say that there is a primary station which is unique, and there are secondary stations which are in number many. So that is why whenever the primary station interested to send some information, or whenever the primary station had some data to put the data to be received by the receivers, so it has to follow certain function. Similarly, the primary station wants to receive data, then it also follows some kind of a function. So these 2 procedures are named as select and poll functions. If you see the screen and its function, so on this particular case, the actual scenario is representing the select operation where the primary station is interested to send some data to the secondary stations. So that is why one frame is referred here as a SEL. That means it is a select function where primary station is sending data to the secondary stations. So vice versa is not possible here, that cannot be called as select function. So select function is a function in which primary station is necessary to send its data to the secondary stations. So that is why it is called as select function. So after sending the frames to the receiver or secondary stations, so the primary station is expecting the actual acknowledgement from the secondary stations, that is also shown in this as ACK frame. ACK stands for acknowledgement. Once the acknowledgement is made by the secondary stations saying that they are ready for receiving the data, then only the primary station is sending or putting its data in the channel, so that the secondary stations can able to take the data. So that is why this particular function is referred as a select function, where primary station is ready to send some frame data, so that it is first of all making the secondary stations to alert whether they are ready or not to receive the data. So that the first step is a primary step, which is called as a handshaking process, you can call, and here the select block is sent to all the secondary stations. The primary station is expecting the acknowledgement for that select frame, and after that it is going to send the data based on the acknowledgement that is made. So this is the function which is called as select function, which is a control mechanism, you can call. Sometimes the primary station has to receive data from the secondary stations, that is also possible, and that is referred as pole function. So you see the figure, the slight modification when compared to this one and the prior one. So here the primary station is actually sending one frame called as pole, which says that any station, secondary station is interested to give any data to the primary station. So that is actual meaning of the pole frame that is actually used in this case. So the pole frame is raised by primary station, sure, and the pole is a frame which will be traveling to all the stations, secondary stations, and any secondary station, suppose it has the data to send to the primary station, then it has to acknowledge by sending an ACK frame. Suppose the station, secondary station does not have any data to send to the primary station, then it can fill the frame as NAK, which says that it does not have any data to send. So that is why this primary station is noticing either ACK or NAK frames from the secondary stations. Whenever the ACK frame is received by the primary station from the secondary station, it implies that the secondary station wants to talk to the primary station. This function is called as pole function. So this is also a mechanism by which you can able to say that the control operation is existing in this overall scenario. So whatever it is, this polling is comprised of two important functions. One is called as a select function, the other one is called as pole function. So in the select, primary is going to send the data to the secondary. In the pole, secondary stations are interested to some data to the primary. So this is the way how the polling is useful in the control mechanism. After that we are also have some other mechanism that is called token passing. Here you have to know about what is a token. A token is nothing but an empty block which actually travel in the total network, so that the any station which is interested to send some information or use the channel, then it can use the token and it can announce that it is interested to send some information to the other stations. So that is the main point in this case of the existence of token, and this token, because it is traveling throughout the network, so that is why it is called as token passing. So in this case of token passing, the network may be organized in any topology, it can follow any topology, but whatever it is, the token should be raised and the token should travel, and the token should be reserved, or the token should have some information in which it is going to express which station is interested to send the data to the other stations. So here there are two important things you have to consider, that is called there is a station which can be referred as a predecessor, and there is a station which can be called as a successor. So that you can identify by noticing the figure here. Let us say that station 2, if you consider, for example, for this station 2, the information the prior to the station 2 there is station number 1 which can be called as the predecessor to station number 2, whereas station 3 is also existing after 2, then 3 can be called as the successor as far as the station 2 is concerned. So like that you can imagine the predecessor and the successor for every station. Suppose if you take 4 is the station, then 3 station is called as the predecessor and 1 station is called as the successor, like that. So you can consider the actual the scenario of predecessor and successor. So that is why this particular architecture is showing by following any topology. So there is a token that should pass to the overall the architecture that is there. So by following ring architecture, by following bus architecture, by following star topology, but whatever the topology is there, but token is a common factor which can travel throughout the network. So that is why it is called as token passing. How the actual process can be carried out here can be represented in the form of a flow chart. So let us here you understand better by following the steps that are there in the token passing procedure flow chart. So let us start the procedure with the start block, and every station, let us say there are 4 stations, 1, 2, 3, 4 like this, and every station is let us say waiting for the token. So because token is passing throughout the network, so that whenever the station is interested to send some data, let us imagine that 2 station is having some data readily available, then it has to wait for the token to say that information it is readily available for sending some data. Then whenever the frame is reaching to station number 2, immediately it capture the station the token by the station number 2. Then because the station number 2 is already with the data, then data frame will be filled in the actual process. Before that it is going to check data frame to send or not. Again it is a question. Even though token is reserved by taken up by station number 2, but it doesn't have any data, there is no meaning of reserving or taking the token into consideration. So that is why there is a question here. That is why data frame is there to send or not is another important point you have to consider. Suppose data is there, because already I told you that station 2 is having some data to send, then because data is available, then it can put this data in the form of send a frame. So that is also over. Once the frame is sent, then how long it has to send the frame, because there are so many other stations which actually are there to share the channel. So every frame for its actual transaction so will be allocated certain time. Once the allocated time is over, it is expired, then automatically the token will be released, and then automatically the channel will be kept free for other stations. So that is actually noticed in this case. Allocated time expired. Suppose if it is no it is not expired, still under the control of station number 2, then it automatically takes the turn to go on sending its frames data to the other stations, so that it can be carried out. So how long? So there are 2 steps. One, once the data is over, then the station 2 can be released, can release the token for the other stations. So that is one step. Once the data is over, the token can be released by the station number 2, or once the allocated time is expired, then also the token should be released. So these are the 2 possibilities of getting the token free, and so that the other stations can able to use the the token. So that is why this particular process of token passing is very important. So here token is playing a very important, which is an empty block, in that the stations are waiting for the token to capture for their operation. Suppose at the same time station 2 and station 3 are also interested to use the actual channel, but so it is not possible simultaneously, because the token, whoever is actually reserved that or taken into consideration the token, so only those stations can have the chance to send the information from its end to the other station. So that is why the token capturing is very important concept. Based on that the information can be carried to the other stations. So here we started with the actual the process here by the start step, and of course token is playing a very important role. Token is able to be captured by the other stations, and this token can be released in two conditions. One is that when the data is not there to send, then automatically token will be released. Otherwise, when the time that is given allocated to the station is expired, then also the token will be released, so that the process can be stopped here. There are some situations where there is by mistake station 3 is captured the actual the token, but the moment it is ready to send some information, but it does not have any information, then automatically the answer is no, the data frame is no, so it is going to release the token, and thereby the token can pass to the other stations for their need. So that is why this particular token passing is a very important technique where every station will have some chance by utilizing or by capturing the token and utilize it for their communication purpose. So this flow chart is again explained in terms of the description like this. A packet called a token circulates through the ring, and when a station has some data to send, it waits until it receives the token from its predecessor. So whenever 2 is there, as per the example is concerned, whenever station 2 is there, station 1 is the predecessor, the token will be from station 1 only, it will reach to station 2. So that is why the predecessor is a very important station which can release the token, or which can actually pass the token to the actual successors of the other stations. So that is why the token will be from the predecessor, and it will be captured by the station, and it will pass through the successors and so on. So that is why this particular token passing is a very important thing. And here when the station has no more data, then it has to release the token, allowing the other stations to get the chance, and the station cannot send data until it receives the token again in the next round. Suppose the station has 2 data frames, but the data 1 is sent and the token is released, then it cannot again automatically take the token into consideration to send the data frame 2, because again it has to wait for the capturing of the token, and once it is done, then only it can able to get its data to transfer. So that is why this is a procedure of passing the token and capturing the token and sending the data, and once the data sending is over, then it has to release the token, or when the time expires it has to release the token. So that is why when a station receives the token and has no data to send, it just passes the token to the next station. So this is the way how token passing. Also we have seen various protocols or procedures related to taking turn concept. Here the protocols are meant for utilizing the channel in a controlled way. So that is why we have visited reservation procedure, polling procedure, token passing procedure. So that is why after noticing this particular lesson, I hope that student is able to know what actually the taking turns protocols means. Similarly, what are the details of reservation, and what are the details of polling, and what is actually token passing and how it actually works out. So this is the way how you can able to understand about actually the token passing protocols. Thank you.